Particles. Everything on Earth is made of elements. The planet, the ocean, the atmosphere, and all life. But what are elements made of? Elements are the building blocks of matter. On Earth, there are 90 elements. Carbon is one element. Aluminum is another element. Gold is a third element. All of the elements are different from one another. Each element has unique properties. What are elements made of? If you cut a copper wire in half, you have 2 smaller copper wires. If you cut each of those short wires in half, you have 4 really short copper wires. If you cut those in half, you have some little bits of copper that do not look like wire anymore, but they are still pieces of the element copper. Imagine cutting one of those bits of copper into 1,000,000 tiny pieces. Then cut one of those tiny pieces into 1,000,000,000 pieces. The pieces would be too small to see, even with a microscope, but they are still pieces of the element copper. Now let's look at the top of page 24. The tiniest possible piece of an element that has all the properties of that element is a particle. Particles are too small to see. What do you imagine they would look like? At the top of page 25 is a graph that shows the copper particle. Copper wire cut into small pieces is still the element copper. This pile of copper dust is made of tiny pieces, but copper particles are even smaller. Copper particles cannot be seen with a magnifying glass or even a microscope. This symbol represents one copper particle magnified billions and billions of times. At the bottom of page 25, it says, if you keep cutting the copper bits in half, you will finally end up with the smallest possible piece of copper. The smallest piece of copper is the copper particle. If you cut the copper particle in half, it is no longer copper. We can represent the copper particle as a ball labeled with the element's chemical symbol Cu. Unique particles. We will use particle to describe the smallest piece of any substance that is still that substance. The element copper is made up of copper particles. The element aluminum is made of aluminum particles. The element gold is made of gold particles. Each of the 90 elements is made of its own kind of particle. Other substances you have worked with are not pure elements, but they are also made of particles. The particles of elements combine to make millions of different substances. Each new substance is made of its own unique particle. This means that there are millions of different kinds of particles in the world. How can we represent particles when elements combine? Turn to page 26. Let's use water as an example. 2 hydrogen H particles and 1 oxygen O particle can combine to form the substance H2O. The chemical formula for the water shows that the water particle is made of 2 hydrogen particles and 1 oxygen particle. Diagram 1 shows one way to represent the water particle. Sodium bicarbonate is another substance. Like all substances, it has a unique particle. Its chemical formula describes the sodium bicarbonate particle. The chemical formula for sodium bicarbonate is NaHCO3. Diagram 2 shows the element particles that combine to make 1 sodium bicarbonate particle, which are 1 sodium, Na particle, 1 hydrogen, H particle, 1 carbon, C particle, and 3 oxygen, O particles. The sodium chloride, NaCl particle is small. It includes just 2 particles, 1 of sodium, Na, and 1 of chlorine, Cl. Magnesium sulfate, MgSO4, is a larger particle, made of 1 magnesium, Mg particle, 1 sulfur, S particle, and 4 oxygen, O particles. The sucrose, C12H22O11 particle, is the largest of the substances you investigated. Take note, how many particles of carbon C are in the sucrose particle? How many particles of hydrogen H? Oxygen O? What is the total number of element particles that combine to make up the sucrose particle? Particles of common substances. The elements hydrogen and oxygen combine to form a water particle. The elements sodium, carbon, oxygen, and hydrogen combine to form a sodium bicarbonate particle. Particles representing particles. Particles of substances can be lots of different shapes. Some particles are long and thin, some are bumpy, but even the largest particles are far too small to see. Even though particles are different sizes and shapes, you can model them as arrangements of little balls. Each ball represents 1 particle of an element, labeled with the element's chemical symbol. You can draw the little balls in different colors for each element to highlight the differences. The little balls can be connected to represent the particle of any substance you can think of. At the bottom of page 27, you'll see that just as everything you eat is made of different combinations of ingredients, those ingredients are made of different combinations of element particles.